of year. But I think we've got some of the key people that we were hoping to see join into the discussion. My name is Sandy Starkweather. This is a joint call with the terrestrial and the observing teams this month. So for those from the terrestrial team, welcome and thanks for joining in on this discussion. We really need your expertise to help with what we're trying to get off the ground here today. So our topic today relates to wildfire smoke detection and forecasting, and really looking at it through the observing lens and what the sort of underlying observing system is, what it has to offer, how it may or may not be exploited to the best advantage, what kinds of gaps we need to be thinking about moving forward. These are some of the things we wanted to talk about today. To prime the pump, we've got Bill, is it Soberg, or am I pronouncing it correctly?
Schoberg. Yeah, pardon? No, that's fine. Schoberg.
Schoberg, okay.
Bill Schoberg. Yeah.
Joining us from the JPSS Arctic Initiative to give us a readout on the fire and smoke initiative of that group and kind of prime the pump for the discussion further. And then following that, we're going to dive into a visualization mapping exercise that has been something we've been trying to do from within the project that I manage, the U.S. Arctic Observing Network, to try to create some more of a sense of the landscape around different observing challenges and applications. And our hope is that what we show and start here today will sort of prime the pump and maybe be able to get a small task team organized. This is a continuation of some of the work that Ed Washburn had started from the EPA side last year. I'll give a little bit more of the context that Ed created further down in the call, but it is one of the documents attached to this meeting announcement was the work that Ed did before he retired from EPA, and we're certainly picking up on that thread in this meeting. Because Bill can't be with us for the entire call, we've moved the updates, the member updates down to the end of the agenda. So we'll make sure that we leave time for hearing from folks before we have to leave. Because our call is small today, it would be nice, I think, for folks to just quickly say hello, who they are, and what their connection is to this topic. So having gone myself, I will maybe I'll just read names down the list in the order that I see them. Meredith?
Hi, I'm Meredith LaValle. I am with IARPIC. I run all these meetings and manage the teams, and I work and live in Anchorage, Alaska.
Thanks, Meredith. Next is Sarah Bowden.
Thanks, Sandy. This is Sarah Bowden. I'm in DC and I'm the Executive Secretary for IARPIC.
Thanks, Sarah. Allison York.
Hi, I'm Allison York. I'm the coordinator for a unit at the University of Alaska Fairbanks called the Alaska Fire Science Consortium. We're funded by the Joint Fire Science Program to work directly with Alaska's fire managers and try to help them get improved science and do science delivery of existing science. So we're basically here representing the actual suppression and management forces.
Great, thanks, Allison. Brendan Rogers.
At the Woods Hole Research Center, I do quite a bit of fire-related research in Alaska and Canada, and I'm involved with the Terrestrial Ecosystems Collaboration Team and the Fire Working Group.
Great, thanks, welcome. Marguerite.
Oh, hi. I'm at NAU, Northern Arizona University, and I am associated with the Permafrost collaboration team and also the ecosystems one, and I'm actually just joining because I'm interested.
We welcome interest. Thanks for joining us. Will Ambrose.
Will Ambrose, I'm at Bates College, and along with Sally and Sandy, I'm the co-lead of the Arctic Observing Systems sub-team.
And next I see a number, a 240 number.
That's probably me. This is Sally McFarlane from DOE. I'm currently on the street in DC, which is why it's probably loud right now. I'm transiting between meetings. But I co-lead the Arctic observing team with Will and Sandy, and I manage the atmospheric radiation measurement sites. And so I'm interested in wildfires mainly from a aerosol smoke perspective.
Thanks for calling in from the street. The 703, which I think is Bill.
That's probably correct.
Bill, could you introduce
yourself? I'll introduce myself as I start to brief.
Oh, okay. We'll come back to you then. Edward Heyer.
This is Ed Heyer from the Naval Research Lab. I have been receiving IARPIC emails for a couple of years now, but this might be the first time I've actually connected to a meeting, but this is exactly one of my strong interests, so I wanted to listen in.
Oh, great. And you said Naval Research Lab?
Yeah, we're in the Marine Meteorology Division of the Naval Research Lab in Monterey, California.
Oh, great. Okay, welcome. Thanks. Jeremy. You're on mute, Jeremy.
Should be doing this from my phone. Can you hear me now?
Yep.
All right. I'm Jeremy Littell, co-lead of the Terrestrial Ecosystems Coordinating Team, along with Steve Gray and formerly Eric Kosicki. We'll see how that pans out. I'm also with the USGS Alaska Climate Science Adaptation Science Center here in Anchorage, Alaska.
Super. Thanks. And then Bill Manley.
Hi, I'm at the University of Colorado on the team that helps with the Arctic Observing Viewer, which is an online tool for collaborative mapping of observing sites to better plan and implement networks.
Welcome, Bill. Is there anyone we haven't heard from?
Hi, this is Emily Osborne.
Sorry, Emily.
No, it's okay. I work with NOAA's Arctic Research Program, and I'm one of the co-leads of the Environmental Intelligence team. And I've worked with Sandy as she's worked very hard to develop USAN. I'm really excited to learn more about this wildfires task and excited to be on this call today.
Welcome. Thanks for joining us, everybody. Anyone else that we haven't heard from? Great. Okay, well, so let's, Bill, if you would dive right in, we'll hear the readout from your meeting last week, and then roll into our exercise.
Okay, very good. So thank you very much. As I was talking with some of the folks earlier, JPSS program has been involved with the IARPIC effort, and Aaron Lanes and Bonnie Reed have been a part of that. I certainly have been following along. So this is my first time to engage directly. And how appropriate. I'm actually sitting in Soldotna, Alaska on the Kenai, just about ready to head back to Virginia, and taking a little time after the Arctic Summit. And I know that on the website for this meeting was the link to the Arctic Summit. I'm going to talk kind of in general, give you kind of an overarching information on what we're doing. I'm not going to go through the Arctic Summit per se, but it was certainly, as you look at the agenda, we were up here with exactly what this committee is all about, trying to connect with the user community, trying to look at what capabilities and products are available to help the user community. And we spent an entire day in Fairbanks at the Alaska Fire Service and talking about, I think it was the 7th, May 7th, that Monday, talking about satellite capabilities, talking about what's going on, kind of walking through the mission of the Alaska Fire Service, and even got over to meet some smoke jumpers and see their facility and talk with them, and that was really, really important. So the Fire and Smoke Initiative is one of many. So let's go to the next page. It's part of the JPSS Proving Ground and Risk Reduction effort. And what's important here is Fire and Smoke is not just a JPSS effort. We have pulled GOES into this, the GOES-R program, to kind of bring an all-satellite approach. There are several other initiatives that are like that. And in fact, we have an Arctic initiative in addition to individual initiatives. Let's go to the next slide. So we got started on the Proving Ground and Risk Reduction program back in 2012, shortly after the launch of SUMI NPP. And we have gone on ever since. The idea of the program is that we JPSS would fund particular projects, particular efforts, research with a direct benefit to the user community. And that's kind of how we started with Fire and Smoke, was talking with the user community, and not just in the Arctic, but certainly with Arctic applications. So the next slide is the success of these initiatives are really based on working together as a team and starting with individual projects, but working together as a team and kind of testing these capabilities to see if they're really useful. And if they are, we would transition kind of research to operations, products to operations, and actually where they're not really successful, this team works together to try to tinker with them to make them successful. So slide 5 shows a list of the initiatives. And what's interesting is on the in the light blue are new initiatives that have stemmed from the call for proposals that we put out in 2017. So we're always looking at these initiatives. We're looking at ways to make them better. We're looking at ways to help focus in and look for additional users, additional people that might find them valuable. So the next slide shows some of our initiative partners. And I certainly could have put the Alaska Fire Service up underneath Alaska there, but when I go around, I guess, to update the slide, I will do that. But we're just broad brushed and lots of people involved. So next slide. And how does it work? I put this as best practices, where we're always looking at objectives, initial objectives as we stand up an initiative, and looking at new objectives or redefining objectives, but always trying to keep a clear focus on what we're trying to do. Frequent user interaction. I actually lead 3 of the initiatives, including the Fire and Smoke, facilitate them. And everybody thinks that meetings are a waste of time, but I found that if you don't have meetings, if you're not meeting together, if you're not talking, chances are you may not be doing much. And so by bringing people together, by looking at the overall initiative working group, but also smaller working groups to handle particular sub-initiatives or particular efforts, such as Alaska and Fire and Smoke in Alaska, then looking through defining key milestones, and then those things that are important, we transition to operations. So when we started with Fire and Smoke, we just wanted to create a forum to allow the stakeholders with the Fire and Smoke, the satellite Fire and Smoke products, to just interact with the developers of those products. And it's amazing. I've actually had several people say that this has changed their life, and that might be something that you think, oh, that's an overstatement. But if you're a developer and you've been working on a particular capability for years, but you've never met anybody who actually uses it, never met anybody who finds it valuable, never had a chance to see the value of that, once you get into an initiative and you're talking with the products and the users, and then you find out that, hey, it is important. What I'm doing is important. So we wanted to, again, a chance to bring the geostationary and polar orbiting satellite capabilities in together. We wanted to see what the current state of affairs are and what could be done to improve things. Then we established methodologies and procedures to move forward, do some operational demonstrations, and to like the Arctic Summit, to meet with people, to understand the mission, and then those things that are good, we want to find a way to transition those. Okay, so on the slide 9, I just picked this. This is just one meeting and the participants. So I guess I would like to think that if people find it useful, they want to join in and attend those meetings, you might recognize some of those names. So this is how we keep track of things. Slide 10, what we've done, we have, as I said, gone out, tried to understand what the fire is all about, how the fire support is happening now. We've met with key stakeholders. We have looked at the fire radiative power and active fires, which I'll talk to you about in a little bit. We brought air quality in because that smoke moves, as you know. And where that smoke is moving and at what level it's going to move at, that's an important thing. So we have met with the IMETs, the National Weather Service IMETs, and gone to their conferences. And then we've looked at how these products have worked in key fire events. A lot of our focus has been on the western region of the United States. Alaska has had a couple of since 2015, of course, was a big fire outbreak, but subsequent to that has kind of been quiet, but we certainly have tried to stay connected there. Okay, next 11. Slide 11, I want to talk to you about a little bit about the capabilities in these satellite programs. Both, as I said here, both GOES and JPSS have that capabilities. The polar imagers have a higher spatial resolution, and especially in the Arctic, they have good temporal resolution as well. The geostationary have, of course, the highest temporal resolution, but they don't reach as far into the Alaska region and into the Arctic region, if you want to look at it that way, as the polar orbiting do. So getting those fine details of where the fire is, the size of the fire and everything, they're a little more difficult in the Arctic using geostationary. But using both of those capabilities together, I think it works out fine. So we have the day-night band, which of course, you don't see a lot of fires in the winter nights of Alaska, but certainly are critical in the continental United States. The ABI, we have worked with them to look at their fire products. And as I said, that last bullet, the combination of both geo and polar orbiting will really provide a consistent global monitoring, especially since the polar can go even to other areas of the globe. I want to talk about VIIRS a little bit. These are the instruments on VIIRS on slide 12. I'm just going to go quickly through these. Most of you may know that that NOAA 20 and SUMI NPP in slide 13 are in tandem. They're actually 50 minutes apart. So it's a half orbit apart, and you can see how those move. And it shows, if you just kind of click through it, you see them kind of moving around. Okay. These are the channels. If you click one more, it highlights those channels of value for the fire mission. And then, some are only available during the day. And then, of course, we have the day-night band. Slide 15 shows kind of the background in terms of the swath width, of course, which is very important, again, up in the Arctic with that overlapping swath width. You get more than 1 or 2 passes per day, for sure. And so I want to show you now, I didn't take the time. It's not quite right to say I didn't have the time, but to show specific fire products and smoke products in Alaska. But here's some that you can just imagine if you transport them northward. This is the sort of thing that you'll be able to see. You can see the fires on the right. And depending on which channel you use, the fire will show up differently. You can show, the day-night band shows the smoke and where that smoke is going. And what's really interesting, although again, in the Arctic, maybe not so much, but you know, that around the big city areas, you can really pick out the fires even in those areas, especially with the geostationary, where you can see the fire boundaries move and change over time. And that's kind of what, if you kind of click on it, it'll show you that. This is the slide that says Oklahoma fires. Of course, fires don't happen independently. They are all part of the environment. And so this one shows, on the left, it really shows the fires moving out of Oklahoma and then being caught up in a frontal zone. And on the right, you can see a little bit of the fronts, you know, the thunderstorms. It's a little odd to think of smoke in a thunderstorm, but it actually happens. And then if you click through, it shows you a legend where the fires are, where the thunderstorms, and even in VIIRS you can see the lightning. Okay, and then this is the M-band showing how the fires show up in Oklahoma, Kansas, and Texas. If you go to the Thomas Fire, again, if you're looking, you can see about the middle of the screen where you can see the fire boundary kind of moving out. They had all kinds of problems, for those of you who might know about that particular fire, with power outages and all kinds of different ways of screwing up life in California. But it's really powerful to see the fire boundaries, and even though we don't forecast the fire boundaries, you can just by watching it, you can have some idea of where they're moving, and that's the power of satellite imagery. Okay, again, some pictures of the Thomas Fire. You can just move through quickly. The one thing I wanted to talk about is the HRRR-Smoke model. There is a link that we probably don't have time to go to, but this is the HRRR-Smoke model, and we do have that model up over Alaska so that we can see. Now, what's important is we have the VIIRS fire radiated power as kind of as initial conditions for this model to be executed. So again, you think, wow, if I know where the fire is, I know where the smoke is currently, and then use that in these models to kind of move forward with that. That's the concept of the HRRR-Smoke model, and we have done that successfully. And we have brought the GOES ABI fire radiated power into that as well. So let's see, you guys can kind of look at this maybe because this can get a little technical, but we have mapped the fire radiated power over the HRRR grid, 3 by 3 kilometer grid, and then use that to kind of move things forward. This is what if you were to pull up rapid refresh, Noah, you would see this, and you can kind of click on one of these and see the smoke forecast for July 19th, 2017. And obviously, you know, you would see today's. We also have a window over Alaska. We kind of open and close that seasonally. So during the winter, where we're fairly certain there won't be any fires, we kind of, because it takes computational time and effort, we close the window and then we reopen it again about this time. In fact, I should have checked, but I didn't. I'm not sure. It may even be open right now. And we're looking to, if you go back to 20 real quick, we're looking to, you see the HRRR-Smoke model in the green, inner green thing. We're looking to get these fire radiated power into the WRAP model, which is the bigger white square that initializes the HRRR, so that we can pick up places along the Arctic a lot better. Now, we have a window for Alaska. We could open a window in Canada if that were necessary, but right now, if we get it into the WRAP, that would be better. Okay, so on to slide 24, back to slide 24. We are looking at vertically integrated smoke, and 23 talked about surface smoke. So that's an effort to kind of say, is the smoke supposed to be forecast down towards the surface as it moves out of the fire, or is it going to stay aloft? So if you see the link and see the product in vertically integrated smoke, but you don't see it in the near surface, then you can say, well, then that smoke over that area, northern South Dakota, or northern South Dakota, is going to be elevated. And then we try to actually look and see if that's what happens. We have since we have been working with the user community, and this is what's key, for a couple of years, we came up with a visualization of this smoke model over zoomable maps instead of just over specific regions. And so you can zoom in. Those are fire-rated powder points. Those are where the fire's in. You can zoom in and get these products a lot easier than trying to click from region to region to region. So that's the strength of this type of initiative. You move on to 25. Again, the visualization here is different. We are tinkering around, seeing if that might be something that would be very useful for the people using these products. Slide 26 shows the HRRR smoke model. I guess that's a Canadian fire right there, but that is the section, the regional for Alaska. So we're able to pick up parts of Canada as well. So what does the future hold? On slide 27, we're working to get ready for the Alaska 2018 Alaska fire season. We work with Go 17 as it comes on board. It's not yet. So their products are not yet available, but when they are available, we'll get those into the smoke model. Then we were up certainly at the Arctic Summit, and there were some things, especially with the Alaska Fire Service, it was clear that there's some additional work that could be done. And we continue to look for field experiments. We're actually going to be working with FireX that's coming up. I had some slides, but I took those out because I knew I was going to run out of time. And so we're just looking for various forums, experiments, people to talk about these initiatives and to help make them more valuable to the fire community in general. And I think that is it. The next slide shows the launch of NOAA 20 and our website. So how did I do? I took 40 minutes. Sorry about that. I took 5 extra minutes.
That was really informative. And so we certainly have time for a couple questions before switching gears. Questions for Bill?
Yeah, this is Will Ambrose, but that was great. Can you just briefly describe how the information you get from these models and your visuals get back to the people in the communities who are likely to be affected, particularly by smoke?
Well, okay. So I'll give you what is happening, and then I'll give you what could be happening. So what is happening is often the National Weather Service weather forecast offices will take these imagery and smoke forecasts and put them up on their various websites and use it to reach out to the community that way. Obviously, by working with the IMETs and Alaska Fire Service, we're hoping that in their weekly briefing that we sat through up with Heidi up there at the Alaska Fire Service, that they would be using it that way. But the reality of it is, for example, the HRRR model website is a public website. So it's really possible that anybody who is concerned about smoke, any public entity that is concerned about smoke, could just jump up there and see how things are going. Obviously, we work through air quality. We work through, the IMET and the fire, the National Weather Service fire folks, the Alaska Fire Service folks, to reach their user community. But, you know, the TV station could get up there, grab some of the imagery, grab some of the smoke forecasts, use it on their own. So does that answer your question?
It does. Thanks very much.
Other questions for Bill? Bill, I have a question. So are most of the data products that you're putting out through the Fire and Smoke initiative imagery, or are there sort of gridded data products that modelers can use as initialization fields that are available for download somewhere?
Well, that's a good question. So probably the answer to that is all the above. So when we started this initiative, we kind of started with the thought, you know, forecasting smoke is really critical, and how can we get these fire radiated power and active fire information into a model that would be of value to help initiate it and take the smoke where it would go based on the model winds and the model, you know, all the other things in the model, in the HRRR model. So we focused on the HRRR, and but as we moved along, we realized, you know, there's a lot of other models out there, you know, the blue smoke model and these other models that are out there that could also benefit from this. And so we have, in fact, we set up a small working group just for that purpose, to identify all the smoke models that are in use, the Canadian smoke models and others, and to see how these satellite fire products could be of value to those models. And we've talked through Colorado has a model. So we've talked with probably 3 or 4 model developers about just this sort of thing, how that can happen. And so, and we look forward to continued interaction. So again, the initiative is positioned to kind of respond to the needs as they come forward. And since I run 3 of these, it's not at all uncommon for somebody to say, well, why aren't you talking to the Navy? Why aren't you talking to these people? And I'm like, bring them forward, connect us, you know, and we'll talk with them, and we'll see how our capabilities can be leveraged in a lot of different areas. So we count on these initiative teams to elevate the right questions and help hunt for the right answers.
Super. Well, that was really helpful. And if I don't see other hands shoot up in the air, I might transition us into our next topic, because I think that what you just said and some of these questions are going to be relevant for the exercise we wanted to float in front of the group today. Meredith.
Okay, well, the one thought I'll leave you with is, if you go back to the list of initiatives that we have, there's a lot of other things that are Arctic applicable, and we're certainly river ice and flooding. We're looking at the river. We're dealing with right now several ice jams that are causing flooding right around Talkeetna, with that knocked the railroad tracks out of the way. So there's a lot of other Arctic applicable things that JPSS and the satellite program could be working on, and could be working on other things. So I'll leave that thought with you.
Great, thank you. Yeah, and Aaron and I have been trying to put our heads together to get a better interaction between IARPC and this initiative. So I think this is a great start.
Okay, well, I'm actually going to drop off the phone and go around the Turnagain Arm and see what's going on out there.
All right.
On my way to Anchorage.
Drive
All
safely.
Right? Thanks a lot. Bye.
Thank you. Meredith, is it easier for me to share my own slides, or for you to pull them up?
It depends on what you're doing on your computer. I can have them up. I'm also taking notes. So if you're not doing anything, if you don't need it for another reason.
Okay, I will share my own screen then. Okay, so it would have been great to have somebody from the JPSS call be able to move forward through this exercise with us, because it sounds like it's very relevant for the activities that they've been doing as well. So what I prepared here was a little bit of a slide deck, and for those of you who remember, it was on a terrestrial call last fall that Ed Washburn came in from the observing team to share and preview some networking work that he had been doing on behalf of USAON through EPA to try to identify some actionable observing system steps that were within the EPA mission area related to human health and ecosystem health that were of high criticality for Alaskans, and that could be supported through improvements to thinking about the observing system and gaps. And through that work, they arrived on this topic of wildfire smoke detection and forecasting. I uploaded a document to this meeting, which is a document that Ed had been networking and reaching out to a lot of people last year to identify within EPA, within NOAA as well, within the academic community and other agencies, who are the folks focused on this, what are they bringing to the table, and how could we potentially stream together these efforts a little bit better. Oh, and thanks, Meredith, just put the link in the chat for that document I described. And so that has, since Ed retired, from within USAON, which tries to identify this task-based work and support it and bring it forward with better partnerships, we've identified an approach that streams along what we've talked about on our USAON calls before, which is looking at sort of the value tree of different observing systems, how they feed forward into different products and services, different models, and different public services, and ultimately support what we've also discussed quite a bit in this venue before, which is the societal benefit areas, or the Arctic societal benefit framework. And so through this assessment, and so I've just developed a kind of pilot draft of what we'd like to do with the smoke detection and forecasting that's based on something we've already done on sea ice. So I'll walk you through what we found useful for the sea ice and to see if this maps well to what could be done for this topic. So first, and similarly to JPSS, we want to clarify the user base. We want to identify what the barriers are to the efficient exploitation of the observing system that we have. And then we want to look down the road to the requirement side of what we're going to need into the future. I'm not sure if the essential variables part of this conversation is going to be as critical or as useful as the first three bullets. But in thinking about the long-term development of the Arctic Observing Network, we're trying to use a concept of broad essential variable categories as organizational units. And so in this sense, wildfire smoke could potentially be considered an essential variable and a means to organize the community around its observation. And so I'll talk you through this example that we did for sea ice forecasting, and then we'll look at this straw man that I pulled together for wildfires from Ed's document. And so starting on the right-hand side of the document with the components of the observing system that are relevant for sea ice forecasting, what we did is we zeroed in on just this one specific forecast model, the Razum-Ezrel forecast model. And we asked the people who were leading this model development, what are the observing systems that you're critically relying on to generate this model? So we worked through this kind of parameter layer. looked back into where they're downloading these products and services, what websites they're going to, what model outputs that they're using. So in this case, they're using a lot of model outputs from the NOAA weather model. They're using inputs from a Norwegian ocean model, and then some satellite data related to sea ice. And so that's the right-hand side of the diagram. This is the underlying observing system that's supporting this one product and service. And then feeding forward to the left-hand side, we're looking at where they're providing their model outputs to. So in this case, the Alaska Sea Ice Program, the National Ice Center, the research community, and through campaign support as well. And then from there, we can begin to look at what societal benefit areas are being supported by this activity and by consequence, the underlying observing systems. And in creating a series of these maps around a given topic, so imagine swapping out this model and putting in the Navy sea ice forecasting model, or the National Ice Center ice analysis itself, or other experimental products, you're going to see a different tree of observing system inputs. Some things will overlap, other things will not. And it helps us explore what some of the barriers are to using different products and services, and to make sure people are aware of what products and services are available from the observing system. So again, referencing the document that Ed had created last year, we began to draft this model of what a similar approach might look like. The yellow box in the center is, again, kind of starting at this product and service level, saying the outcome that we're looking for here are good smoke forecasts. If you look to the left, these are some of the end user services that are found both at EPA and NOAA at the Weather Service. The dotted lines indicate that these products could be developed with an Alaskan focus, but they're not currently developed with an Alaskan focus. Maybe one or several of them would be appropriate. The HRRR model that we heard about is, of course, one of the forecasting products and services we're interested in, but we're also interested in the UAF smoke model. But we need to engage with the subject matter experts to learn more about what the underpinning parameters and phenomena are that they're looking at, and how these map back into efforts like the JPSS satellite constellation or other aspects of the observing system network. In the last call, we had some participants from the LEO network who were coming online saying they thought the LEO network might have a role here. And then, of course, I actually added a layer to this diagram because there are some efforts to develop new sensors and new capabilities that are relevant to the network development. And so I'll just pause here. The slides that I uploaded, they also have some different kinds of questions that an assessment like this might seek to answer. And some of the barriers to data product and service use that we've begun to identify, and some of the metadata that we might want to capture from subject matter experts as we do an assessment like this. And then the resources that Ed created are the last few slides. But pausing here, I just want to hear from folks on the phone and get a reaction to, oh, Jeremy had to jump off the Zoom. Sorry, just get a reaction from folks on the phone about trying to apply what we did for sea ice to the fire and smoke challenge, what it might help reveal, how it might help us organize the space.
Sandy, this is Allison, and I'll start. I think this looks tremendously useful. There are a lot of moving pieces and parts in this space, and a lot of different agency players, and it's been very difficult to wrap our heads around all of it, particularly from the end user point of view, which is essentially what I represent. So I feel a little like I've died and gone to heaven.
Oh.
This looks like a really great start. And I'm really excited because this is exactly the kind of organization and assessment tool that the end user community needs to help us move forward on this. So thanks very much.
Great, Alison, it's really helpful to hear. And so you're going to now, by implication, be one of the first people recruited to the task team.
Yeah, I know, but it's worth it. It's worth it.
This is Jeremy. I'm still on the audio, not on the Zoom. I'd underscore what Alison said and also point to the fact that as our presence and task list in Alaska evolves with Department of Interior priorities, this looks more like the kind of thing that I think we'd be asked to do specifically by bridging, the vulnerability of remote communities in Alaska and also Alaska Native interests. I don't know if there's room for a community participatory approach here from the bottom up. We talk a lot about the science being the top-down parts in terms of forecasting and detection and things like that. But to the extent that we can help with that other part, I'm happy to as well.
Yeah, that's great, Jeremy. I mean, one of the things I think that that this schema can support, as we've been introducing it to more communities, is that communities can really jump in where their interest is. And so, and by communities, I mean research communities, modeling communities, agency, regulatory groups. And so it's really helpful, I think, to having, people tend to fall into one of the columns, whether you're in more of an end user space or even, in the societal benefit areas. I think that's really where you can channel the voice of the community and say, this is the specific objective that's important to us. And then you can go back into that user service arena and say, do we have public services supporting that objective or not? And if not, why? So I think it would be tremendously helpful to get some clarification on, the societal benefits are these kind of big buckets, and then they get kind of segregated down into more specifics that turn into these objectives. So that would be helpful.
This is Moses. I have a question with regards to the LEO network. I wasn't on the
okay. Well, we'll continue to discuss it then. I'm going to drop off for the next meeting that I've got and stay in touch.
Okay, very good. Thanks much. And Moses, I heard you starting to say something, but it was a bit faint.
I guess I should have the mouthpiece a little closer to my mouth. Sorry about that. I was wondering about the last meeting with the ocean folks with sea ice. What were their intentions with the LEO network? Were they looking to be more like ground truthing satellite imagery sort of stuff? With the anecdotal information that we're collecting through the LEO network, how would you see it working here with the fire detection? And nice to hear you there, Alison. And I agree with you. This is pretty neat, and there's definitely some potential for the LEO network here for sure. I'm just kind of curious how it would fit into the bigger scheme of things.
Yeah, so great questions. And on the previous diagram with the sea ice, the LEO network was not explicitly called out in that example. The LEO network was part of the potential observing system resources that Ed had identified. And part of the reason why I have the dashed line there is around this development required concept. This is very draft and preliminary, and I think we would need to put our heads into that. Ed had looked, I think he had spoken with you and Mike Brubaker, along with John Walsh and Olivia Lee, because he was intrigued by the example of how, in the case of fast ice, the LEO network did proactively go, and some observers from within the network were engaged with to proactively go and observe specific things related to fast ice. And so maybe that could serve as a model for something smoke related, but I think it's really an exploratory conversation about what role it might play. Do you have thoughts on that?
Excuse me?
Do you have specific thoughts on that that come to mind right now, or something that you'd want to sit on?
That's something I think I would like to sit on for now. We have a handful of observations from up in the Seward Peninsula area from last year's wildfire. And right now it's just folks talking about the smoke and health effects as a result of fire, wildfires. I would like to see a little more of how Leo would fit into this here, this setup. And I agree with it being in the development required.
Mm-hmm.
But other than that, yes,
Hey,
I think I would just sit on it later.
Was that Sarah?
Yes. Yeah, sorry, my internet isn't terribly stable, so I turned on my video. Can you hear me?
Yes.
Okay, so I also want to second Allison's enthusiasm for this, because I think what you've got going here is an opportunity for the community to weigh in on the left-hand side here, and I'd be so interesting to have a meeting where you could explore those societal benefit areas with them. And I think that at the point where you get those clearly defined, I think agencies are going to see their roles better and provide some exciting opportunities. I don't see NASA really well represented here, and I know they definitely have a role. And so sometimes when you get something down on paper and you see your name missing from it, that can prompt some interest. So I think you've done great work with this in identifying all the parts and then allowing people to build from that.
Great, thanks, Sarah. Yeah, I have noticed that that agencies have a Me Too moment when they see things without their names on them sometimes. So hopefully it's motivating. Are there, so just looking at the outline right now, beyond the HRR smoke model and this UAF smoke model, those were the only two models that Ed had identified. Are there other models that we should maybe be thinking about and reaching out to and networking with folks on?
The operational community relies on what they call the Blue Sky Modeling Framework. And that's something that is deployed by the U.S. Forest Service primarily. They have a program called Air Resource Advisors that they send to areas that are affected by significant amounts of wildland fire and provide local, regional level smoke modeling. So that's definitely a piece to be added in here.
Okay, great, thank you.
I can send you a link to the resource.
Okay, that would be helpful. Thank you. So I just looked at the time and I'm sorry I didn't have my clock more visible. I know we're kind of coming to the top of our hour here, and we were going to provide some time for updates at the end. This is really useful feedback, in particular at the level of enthusiasm. What I really would need for next steps is to identify some people who are willing to informally organize into a bit of a task team to maybe outline what some opportunities are for next steps here. So if you are interested and would be willing, please follow up with either an email to me or putting your email into the chat. I'll put my own email into the chat so everybody has it handy.
Sandy, while you're doing that, I also just want to encourage people to reach out to you and Jeremy, because the Terrestrial Ecosystems Group does have a wildfires task team, and so let's just make sure that we stay very well coordinated there.
Great. Yeah, this could be something that maybe that task team would want to adopt with some facilitation from my side.
Right.
Okay, so quickly before we run out of time, did anybody have any updates that they wanted to share without specific topics attached to them?
I was actually kind of hoping maybe I could just make a really quick meeting plug to this group. This is Ed Heyer from NRL.
Hi, Ed, you're just a little bit faint.
Ah, okay. Yeah, I can do better. How's that?
Great, perfect.
I just wanted to make a really quick plug. Next week, there is a meeting sponsored by the Fire Ecology Association and the International Association of Wild and Fire. It's called the Fire Continuum Conference, taking place in Missoula. I expect some people are aware of it. These meetings attract some scientists from a broad swath, but they also attract a lot of actual land managers and fire responders. But one particular thing that we're doing at this meeting that I think will be interesting things will come out of it, whether you're there or not, is we're having a specific session on the upcoming Western wildfire smoke measurement missions, because there is a large NSF-funded mission occurring later this summer. There is a NASA-NOAA combined mission in 2019, and then there is a lot of course, ongoing effort by the U.S. Forest Service building towards their eventual fire and smoke model evaluation experiment, the FASME. So we'll have the PIs from all of those projects together to do presentations and Q&A at the that Fire Continuum Conference. So just thought that if anybody perhaps was already thinking of going to that meeting, look up our session. It's organized by myself and Nancy French at Michigan Tech University, as well as Jun Wong from University of Iowa on the science side.
Great, thanks much, Ed.
All right, thanks.
Any other final updates? So the observing team was pretty lightly represented on the observing call. Thank you to the terrestrial team for your avid participation. For those observing team members on the call, I just wanted to make people aware that we're taking a pause in the month of June for the Arctic Observing Summit, which is in Davos from June 24th to 26th. And at our July meeting, when we reconvene, we'll be doing a readout from that meeting in addition to covering some other topics. Will or Sally, if you're still on the line, any final words?
I am still on the line. No, this was great. I'm sorry there weren't more observing people here, because I think there's a good cross-fertilization between the two groups, but this was really interesting. Thanks.
I will say that
Hey, Sandy,
I'm just going to note that the next terrestrial meeting will be held with the permafrost and health team on June 19th, and they're getting Paul Schuer, who will be speaking on mercury and permafrost.
Oh, and we should also mention that the atmosphere and health team meetings at the end of this month are going to be picking up the wildfire topic. And so we're going to do a report out from this discussion forward at that meeting. They're going to be focused more on the community level issues in preparation for the fire season.
I'll put a link to that meeting in the chat.
Thanks. And Sarah, you had something also?
You stole it, Sandy. We're good. Thanks.
All right, great. Thanks, everybody. Thanks for your time.
Thank you.
Thanks, Sandy.
Bye.
Bye-bye.